Welcome back, everyone. And today we're going to be doing some behaviors, some components that we can connect to game objects. And in the last episode, we worked on creating the hierarchy and kind of setting up some things over here in our packages and letting us select game objects and the hierarchy. So now what we need to do is we need the ability to attach scripts to these game objects so that they run dependent on the objects themselves. So over in Unity, basically it's going to be exactly like this. So you click on an object and it's going to show you in an inspector over here showing you everything that's attached and the variables that you can change. So hold on. We probably don't need that. Oh, we're not even using that either. Just getting rid of some of these warning messages. Oh, we're not even using that at all. Never mind. Never mind. Okay. So the first thing we need to do is we need to create the abstract class for our components. And if you don't know what an abstract class is, it's basically just a class that we can inherit from, that will have all the things that we need on it. And the reason why we're needing an abstract class is because you're going to have multiple scripts using this class, and it's going to be stored as the abstract class or as the superclass. So we're going to call this logic behavior. So any game script that you have that needs like update functions, GUI functions, start functions, etc., that's going to be updated and attached to a game object, it's going to inherit from this. So it needs to be a public abstract class. So all it is kind of like just a bare bones class that just has a few functions and variables. So the first thing we're going to need is the ability to turn this behavior on and off. So we'll have an enabled Boolean. So if it's off, then it's not going to update it anymore. If it's on, then it will update it. Just so if we're not using it in the scene and we only turn it on for whatever reason, we can toggle that on and off. And actually I'm going to initialize it to true, not false. And some other things we need is the name of the class that it's inheriting it from. This will be easier so that we don't have to manually do it, and so that we don't have to use reflection anytime we want to get the name of the script. We're going to keep that as a private. And since it will never be changed, we'll keep it as a final string name. And we will set this in the constructor. All right, and another thing we're going to use, it's not going to be a final, but we are going to need a final method so that the game object that this is attached to will not change. So you can't like take it away from a game object because there's several things that need to be done, like the game object needs to know what's attached to it, and if you just remove it from it, then it's not going to know that it's been removed. You have to remove it from the game object, not remove the script locally, I guess you would call it. So it's just going to be a private game object, and we'll just call it GameObject. That would be a final. I would keep it as a final, but then in the inheriting class, I would have to do like overriding calls in that class every script that I create that inherits from it, and I just don't want to do that. So let's go ahead and do the constructor. We will set the name. So it'll be a public logic behavior. It's going to take in no parameters. And right here we're going to set the name. And how we're going to do that is we're going to use reflection. So we're going to use get class and then get SimpleName. Now, only the class that is inheriting this, it's only going to get that name. It's not going to get this name. So this name will not be logic behavior. So if we create another script that's called like player movement or whatever, that's what this is going to return. It's not going to return the logic behavior script. So now we need to set the game object itself. So we need an initialization function. So we'll call it init. We need parameters, so we'll take in a GameObjectG. And the GameObject class is going to call this method. So you never have to worry about calling this. And it is only going to set it if the game object, if we don't already have a game object. So if you're at runtime or whatever, and you call this function, you try to pass in a game object, it's not going to set it there. It's only going to set it once. So it kind of makes it final so that you cannot change it. And that's exactly how it should be. So we need to see if GameObject equals null, then we're going to set GameObject equals G. So that's very simple. So now we need some like skeleton functions. These functions will be called by the engine. And the reason why we're putting them here as a skeleton is so that every script that inherits this will be able to get those function calls. So we're going to do public void awake. We also need public void update and public void on will render, which this function will be called only if this object will be rendered. So if the object is turned off, this will not be called. If the object is off screen, it will not be called. It will only be called if it's on screen and visible. So if you have a custom class or custom script that is attached to a game object, you will know if it's being rendered or not. So you can add something to this method. For instance, if it only does something if it's being rendered. And lastly, we need public void on GUI. And this function is going to give us access to our GUI methods. So if you try to call it from in here, it's not going to be initialized. So it's not going to work. It's only going to be initialized right here. All right, and then we're going to add one more, well, not one more, but we're going to add a print method so that you all know you call system.out.println you know, something. Oops, well, I spelled that retardedly. And that's how you I don't know. Apparently I'm spelling something wrong. But you get what I'm talking about. You have to print, or you have to type all that crap. Oh, because it's not in a function, duh. You have to print or type all that crap just to print something on into the console. Well, we're going to shorten this so that all you have to do is just call print and then something. So, do public void print. And then it's going to take in a string. I'll do s. And then all this is going to do is call system.out.printlns. And that's it. I'm only doing a string just because all these other classes like vector2 class and rect class and whatever is going to have a toString method. So you just pass in the toString method here and then it will print it to screen. Alright, now here is going to be our final method for our GameObject so that it cannot be changed if it's retrieved. So we're going to call private or public final GameObject. And that is going to return the GameObject. So that if we get this GameObject and then try to change it through the getter method, it's going to be final, so we can't do that. So that kind of locks it into place. All right, and then we need the ability to get the name. So let's call public string name. And all that's going to do is just return name. And for right now, that is it. We don't really need anything else for that. At this moment, at least. Later on in the future, we're going to have several skeleton functions for the logic behavior, but for now, that will work just fine. So here's an array list. I'll put it in here. So now we need a list of logic behavior. We're going to call this components. And it's just going to be a new array list. Just copying what's on top. Logic behavior. You could use arrays. You can use lists. Just using arrays just takes a lot longer than using an array list. So I tend to use those a lot more often. So I'll put it under the parent method, I guess. Now we need the ability to get a component, remove a component, and add a component. That way we have full access of getting, setting, and removing components from a game object. So let's do public logic behavior. No, let's do get component first. Get component, and it's going to take in a string s. Alright, so now all we're going to do is we're just going to loop through all the components. So for I equals 0, 4 is lower than same crap we always put, and I plus plus. And for here, we're going to do logic behavior B equals components dot get I. So I'm getting into. Oh, hold on just a second.
Look at it.
Okay, I'm back. So we're going to store this behavior, and the reason why is because we're going to use it twice if it's the behavior that we're looking for. So it's just easier than calling components.getI twice. So right under that, we're going to call if b.name dot equals s. Then we're going to return b. And if we go through all of these components and it is not found, then we're going to return null because we were not able to find that component. Now the next one, we'll do remove component. So public void remove component. And this is going to take in a logic behavior. So in order to access the remove component, you need to know the exact, or have access to the exact behavior that we're looking for. Later, we'll also add a string method and do, similar to what we're doing right here. But we don't need that at this moment, and right now we're going to have direct access to the behavior, so we're just going to leave it like this for now, and we'll just add other parameters functions later. So just to make it shorter, because we're going to be looping through it, and so we're going to loop through all of the components, and we're going to say if components dot get I equals b, then we're going to call components dot remove I. Actually, I think I can just call components dot remove b. I don't know. I'll check that later. I think we just took the long route. But whatever. It still works. We'll check it here in a few. So next, we need the ability to add the component. So we're going to call public void add component. This will take in, once again, a logic behavior as b. And I don't want a void, I want a void. And all this is going to do is this is going to call b.init, and it's going to pass in this. And then we're going to add it to our components. So we're going to pass in our behavior that is inheriting from logic behavior. And then we're going to take that logic behavior and we're going to call the initialization function and set the game object, and then we're going to add it to our list of components. So it's very simple. It just does it for us. So let's we'll create a new package, I guess. We'll call this package game. And for now, I mean, possibly later too, I don't, there's still very iffy things about what I'm going to do in this series, like how I'm going to do it. But for now, it seems good to have a game package and have all of our things from our game itself that is not engine related into a game package. And if we need to, we can add things that actually just import it in there into that package. I don't know. We'll see though. So for right now, we're just going to create a class. And we'll just call this class test. It's going to be inside of the game package. And basically, it's just going to be like an empty behavior, basically, just so that we can test it for now. So we'll call this extends logic behavior. This needs to import engine.logic behavior. And that is it for components for now. I mean, we still have to display all this stuff, but for now it's good. So right down here, what I'm going to do is we're just going to test it a little bit just to make sure everything works. Because, well, you never know. Knowing me, I typed something wrong somewhere, but we'll see. Alright, so we're going to call GameObjectG equals new GameObject, and I'm going to name this object, call it Tutti Frutti. And we're going to say g.addComponent new test. And that is it. So whenever we add a component, we just pass in a new component. If you I mean, I guess you could too if you said like test t equals new test and then you pass in t here. It should work as well too. So if you put t equals new test and then you say call some functions or whatever, do some mathematics, and then pass in t here, that should work as well. But to be on the safe side, normally this is what you want to do. So, well, I mean, yeah. Yeah, because we'll have an instantiation method too in the future. We'll put an instantiation method in the GameObject class or inside of the logic behavior class, actually. that will do a lot of the, GameObjectG equals new GameObject, blah. It'll instantiate stuff in the scene. So go right here, and we're going to say system.out.println actually, no. Let's go test t equals g dot get component test. Oh, gotta cast it to test. And then we'll say system.out.println t.name. And that should print test. And there it is, test. So it did not give us the logic behavior name, it gave us the test name, just like how we needed. Now I'm going to say, so we know that the name works. So after the add component stuff, I guess, we're going to say string n equals g dot name. Wait, no. String n equals t dot name. And then we're going to try to change it. Say n equals some other name. And it stays the same because it's final. Now, the last thing we need to do, or check, is if we can change the game object that the script is attached to. So let's go GameObject equals t dot GameObject, and then we're going to say a equals new GameObject. We'll call this new GameObject poop, because why not? Say t, so then we're going to say t dot GameObject dot name dot name. No, dot name. Got me all screwed around. Alright, so that's going to test to see if we have changed that game object that it's attached to. And it is still Tutti Frutti. So, awesome. That did exactly what we needed. So, that is it for this tutorial. Thank you for watching, and next time we will probably get into some of this visual stuff, this inspector over on the right side. So it'll be exactly the same as the hierarchy over here, but we will have it over here. So then whenever we click on something, oh, and here is our Tutti Frutti object that we created. So it is being thrown into the hierarchy. So whenever we click on our Tutti Frutti object, over here in the side, we're going to start showing the components and its variables over here. And then we will be able to interact with them. All right, so thanks for watching, and I will see you next time.